Greetings, friends. My name is John Gabriel, and no, this isn't a repeat of a previous video, but I'm going to be talking a little bit more on the same topic to try and help you understand why what I mentioned to these Greek academics on the site mathematica.greece is so important in understanding not only the new calculus, but also why the mainstream calculus is wrongly formulated. I'm John Gabriel, and this is a new calculus channel. Let's begin. So, you may recall that I initially posted a video requesting someone who is interested in translating my book, and I got terrible responses. I mean, they were all aggressive. None of them had anything to do with the topic, and every attempted refutation at fact was a failure because none of these academics corrected anything I said. And so I decided to post a second comment, and this was a second comment, and I said, "Δεν υπάρχει έγκυρος συστηματικός τρόπος υπολογισμού του παράγωγου." And that means there is no valid systematic method of finding the derivative. And it took me a while, as I said, to post this comment in Greek because my Greek is not so good. And I was in a bit of a rush, and although this actually is true, even in propositional logic is true, this doesn't have to be an equation. For example, 3/4 implies 9/12, okay? And neither of them are equations or propositions in the sense that you have an equation, as you see over here. But in any case, what I could have said, and what I meant, in fact, was, and I made it very clear to them, is that this here is equal to the right-hand side here. In other words, equal to f prime of x plus some expression in q of x delta. Now, what is this expression in q of x delta? I'm going to explain to you very clearly what it means exactly in terms of both the new calculus and your bogus calculus. But before I continue, this little man here, Dimitris Yannikos Syndonistis, I think he's just a general administrator, says to me, "Από όπου και αν το βρήκες αυτό είναι εντελώς λανθασμένο." So he says, wherever you found this, wherever I found it, so he's already insulting me, this is completely wrong. Okay, so now I'm going to show you, without further ado, that what I wrote there is completely right. And let's begin. So now in the new calculus, I'm using this function here, x cubed. In the new calculus, what you have is this definition of the derivative. And this expression here is always the difference between the slope of the tangent line and the secant line. And in the new calculus, it's always 0 because the slope of the parallel line is the same as the slope of the tangent line. In other words, they're equal. So it's got to be 0. But you can't really take that. If you don't really believe that, and I'm going to show you now, you can actually calculate this expression here. And this is the auxiliary equation in the new calculus, with the pink section being m and the orange section here being n. And you can see that it doesn't matter where you go. The derivative will be 3, and q of mnx or xmn is always the same, okay? It doesn't change. So as you can see there, even if I do that and I move along, there are many, many parallel secant lines I can use to find the derivative, right? Now, the same sort of thing can be attempted with, incidentally, so before I continue, this expression is simply the difference in slope between the tangent line and any parallel secant line. So any of these parallel secant lines, which happens to be 0 because if lines are parallel, their slopes are equal, and the difference is 0, isn't it? Okay, so let's look at the bogus calculus. Now, in the bogus calculus, you don't have, this red secant is not a parallel secant. It's never parallel to the tangent line, okay? And this finite difference is equal to f prime of x plus the difference in the slope. So you see, q of xh, as you see here, is the difference in the slope of the secant line and the slope of the tangent line. Okay, so if you take away the slope of the secant line from the tangent line, you'll get the slope, the negative slope of the difference. Okay, otherwise just the difference between these two slopes will give you q of xh. So q of xh is simply the difference of the red secant line, this red secant line slope, and the green tangent line slope. And f of x is given by your flawed first principles method. So in other words, this piece of crap here, which you've learned by heart and never understood and thought was correct, with all your epsilonic arguments and your hand waving discussions, etc., none of this is correct. And you'll see that it doesn't matter. As you reduce this difference to 0, you never have the derivative. And if you get to 0, you have a problem. See, there is no derivative at that point. Okay, so the derivative is meant to be given by this expression. You have to have this equal to 0, but you can't have this equal to 0, because guess what? If this expression here, which is the difference in the slopes, is 0, it means that h must be 0, in which case this finite difference is not well formed, and neither is this. Okay, because you can't divide by h assuming it is not 0, and then later on assume it is 0 to find the derivative. And by the way, you know, an arrogant, incompetent, stupid mainstream academic may say, but you don't understand limits. Well, they know what to do with themselves. They can go and jump off a high cliff, because that's absolute rubbish. What they do in the first principle method is exactly equivalent to what you see here. That is, the f prime of x is equal to the slope of the secant line minus the difference, okay, between the secant line and the tangent line. And that's all there is to it. Now, I tried to explain this on sci.math, and you should see how stupid the people on that forum are. For example, some idiot from Switzerland, Jan Bursa, I mean, a total idiot. And then another guy, Jean-Pierre Massager, also known as Python, really clueless, absolutely clueless, even to the simplest of high school algebra. This information I'm giving you is not really difficult, but it's damning, because it shows that your mainstream formulation is flawed. So now I'll go back here, and we see this little man here. So he says, wherever you found it, it's wrong. Actually, he's entirely wrong, isn't he? And look what he says here when I told him that this here means exactly the same as this very definition here, which is flawed, because L is the derivative. He says, sostos orismos ke katholu kiklikos. He says it's a correct definition and not at all circular. But of course it's circular, because L is f prime of x. And this here is not a definition of any sort. It's a verifinition, okay? Because you have to find L using the bogus or the flawed first principles method, and then with this verifinition verify that L is indeed the derivative. But you have no valid systematic way of finding the derivative in your bogus calculus. Also, your definite integral is incorrectly formulated, and all these things have been corrected in the new calculus, right? And you should see the scorn in this comment here. Venxero am prepi na klapso ina gelaso. He looked at the Gabriel polynomial, didn't understand what the fuck was going on, and he says, I don't know whether I have to cry or laugh. This guy is called M.S. Vovos, and I don't want to tell you what Vovos means in English. It's not a really good last name. In any case, this idiot, okay, this total idiot here, whoever he is, I've never met him in my life, but you see, he hurls insults at me. They all hurl insults at me. And finally, this topic also gets up ends up being closed. Το θέμα κλειδώνεται. The discussion is closed. Okay, so no more time to be wasted on these fools. This is the last time I shall address this topic, and I shall also put this on my other site, to which I'll place a link, because it seems they're trying to close down my YouTube channel. And I'm in the process of transferring all my videos over to the other site. It's very tedious. I don't know if I'll be able to get it done in a reasonable amount of time, because I have over 400 videos, but I am trying. But in any case, any new video I produce will go on the other side too, and I'll try to do 2 or 3 videos a day, transfer 2 or 3 videos a day over to the other side. So become a subscriber also on the other side, and if you're not already a subscriber on my channel, subscribe to my channel, spread the news, click like, very important, because some little dimwits from Sweden like Marcus Cliver and Zelos Malum and other fools who don't agree with me will simply just come and vote my videos down, and others will not be able to learn about this wonderful new knowledge. Okay, so I hope you've enjoyed this little presentation, and I'll try to pick another vexing topic for the next video whenever I'm able. This is a new calculus channel. I'm John Gabriel. Till next time, goodbye.